Hello again, Econ students. This is Professor Grott explaining elasticities. Now, the concept of elasticity is one of the more entertaining concepts in economics once you understand it. Let's get started. Knowing that two variables are related to each other is useful information. So in the last chapter, we used the tools of supply and demand to show how an economic event would influence the price and quantity of a good on a market. So for instance, if there's an improvement in technology that makes it cheaper to produce a good, we said that the price will fall and the quantity will increase. That's what we call a pattern prediction. So we didn't say how much the price would fall or how much the quantity would increase. We just knew what direction those variables were going to move in. And that's really useful information in a lot of contexts. However, a lot of times it's more useful to know how much changing one variable will change another. So how much will the price fall due to this technological improvement? Or how many more units will be produced? Right, sometimes knowing how much is more useful than knowing in what direction the movement will take place in. So all an elasticity is it shows how responsive one variable is to changes in another variable. Or more precisely, an elasticity measures how much a 1% change in one variable will cause another variable to change in percentage terms. So it's equal to a percentage change in y divided by a percentage change in x. Usually x denotes the independent variable and y denotes the dependent variable. So for a given change in one thing, how much will that change another thing in percentage terms? That's all an elasticity measures. Let me give you some examples just to see what we mean here. So crop yield is related to rainfall, and up to a point, an increase in rainfall will increase crop yields. And some scientists went out and measured how much crop yields increase when rainfall increases in Ethiopia. And what they found is that the elasticity of crop yield with respect to rainfall in Ethiopia is 0.4. Okay, so what does that number mean? Well, that 0.4 is just the value of the elasticity. It's positive, so it means that these two variables move in the same direction. So as one increases, the other one increases, and when one decreases, the other one decreases. And it's equal to 0.4. Well, what that means is that the percentage change in y divided by the percentage change in x is equal to 0.4. Now, here we would probably say that the rainfall is the independent variable and the crop yield is the dependent variable. So when rainfall increases, it causes crop yield to increase and not the other way around. So the interpretation here is that if the elasticity of crop yield with respect to rainfall in Ethiopia is 0.4, it means that crop yield increases by 0.4% if rainfall increases by 1%. Or similarly, crop yield will increase by 4% if rainfall increases by 10%, and so on. So these two things are related. Or another example, the elasticity of life expectancy with respect to the body mass index. So we all know that if you become too overweight, that will create health problems, right? But how risky is it to eat that next cheeseburger? Well, here's a measurement that sort of gives to you some concrete information that explains how risky that behavior is. So the elasticity of life expectancy with respect to BMI is negative 0.5. So here we have a negative relationship indicating that when your body mass index goes up, your life expectancy goes down, and vice versa. So the interpretation here is that life expectancy falls by 0.5% for every percentage increase in your BMI. So if your life expectancy, well, it's going to be a little less than 100 years, but let's just say 100. So if your BMI goes up by 1%, that means that your life expectancy is going to fall by 6 months. And then finally, let's look at the elasticity of crime with respect to education. Here we went out and measured this empirically and found that this elasticity is equal to -2, meaning that there's an inverse relationship. And so the interpretation is that crime rates fall by 2% for every 1% increase in education spending. So these two things are inversely related. Why might that be? Well, in general, if people are more educated, they're less likely to be unemployed, and they're less likely to commit crime. So here's something that shows you a little bit more about society's trade-offs. So one of the good things about increasing education spending is that it lowers crime. So you can see that elasticities are really nice because they're unitless. They just show you how a percentage change in one variable causes a percentage change in another variable. So it doesn't really matter what units you measure in. So for instance, if you're looking at the relationship between height and weight, the elasticity would be the same regardless of whether you measure height in inches or centimeters and weight in pounds or kilograms, because the percentage change will be the same in either case. It's really cool because it allows you to compare things that are measured in completely different units. So you can look at things like the impact of education spending on crime and see the relative impact there and compare it to something completely different, like the relative impact of rainfall on crop yield. And these things are measured in completely different units. If they were just reported in normal terms, it would be a little bit more difficult to compare which dependent variable was influenced more by which independent variable. If you put it in terms of an elasticity, it's in percentage changes, and so you can just see that whether the number is bigger or smaller. So for instance, going back to the previous examples, we see that there's a bigger effect on crime when education spending goes up, because the elasticity is -2, than the effect of BMI on life expectancy, which is only 0.5. So here we can compare these two things that are completely different, and it's really easy to get a handle on it. So that's one of the reasons why elasticities are nice. And they're easy to interpret, and you can use them to compare responsiveness of just about anything to anything else. So economists regularly use statistics to estimate the relationship between two variables, economic or social or otherwise. And often the magnitudes of the relationships involved are reported as an elasticity. So when an economist wants to go out and find out more about the world, let's say they want to look at how taxes will influence spending or GDP in the economy, then they'll go out and try to statistically estimate it, and they might report that relationship in the form of an elasticity. So if taxes go up by 1%, by what percentage will GDP fall? Or you can take any two variables. Remember, economics just studies individual choices. So you can look at any two things and come up with an economic theory about how they're related, go out and measure it, and see if it's true or not. And if it's true, try to figure out, well, how much does one variable influence another? This is where economics gets fun. It's really cool because you can use it to study just about anything that you're interested in. For example, a while back I noticed that my wife was complaining about me a lot, and I was curious if she would complain less if I gave her more compliments. I was wondering if she would respond to this incentive in a way that I wanted her to. And so what I did is I spent a week, I figured out how many times I was complimenting her and how many times she was complaining about me. And what I did is I increased the number of compliments I gave her, and I hypothesized that she would be a little happier with me and stop complaining so much. Right? So here was a problem that really interested me, and I wasn't just interested in whether she would be a little bit nicer to me. I was pretty sure she would be, but I was curious how much. Right? And elasticity tells you that. So what I did is I increased the number of compliments I gave her from 3 in the first week to 9 in the second week, or I increased it by 200%. And as a result, the number of times she complained about me fell from 5 times to 1 time, or by about 400%. So she's pretty responsive to my compliments. A synonym for elasticity is just responsiveness. So anytime I use the word elasticity, you could just replace it in your mind with responsiveness if you like, if that makes more sense to you. So the elasticity or responsiveness of complaining to compliments from my wife was equal to negative 400% divided by 200%, which is equal to -2. Her complaining fell by 400% when I increased the number of compliments I gave her by 200%. Right, so for each percentage that I increase the number of compliments I give her, I can expect that she'll decrease her complaining about me by 2%. It's really worth it for me to be nicer to my wife. Now, a little bit later, my mother-in-law was visiting us, and she was complaining about me a lot. And I was wondering if she would be as responsive to me being nice to her. Now, what do you think happened? Well, I tried the same experiment on her. So I increased the number of compliments I gave her in a week from 1 to 11, or by 1,000%. And as a result, the number of times she complained about me fell from 11 to 10, or by 10%. So the elasticity of complaining with respect to compliments from my mother-in-law is equal to -10% over 1,000%, or negative 0.01. So she's much less responsive to my compliments. I think she just likes to complain about me. So it wasn't really worth it for me to go out of my way to be nice to her, because she was going to complain about me pretty much either way. Now notice that there was a negative relationship for both my wife and my mother-in-law, so when I was nicer to them, they stopped complaining about me. That's the direction that I would expect, but the responsiveness of my wife was way greater. Okay, so my wife's behavior was responsive to my compliments. My mother-in-law's really wasn't. So there was an elasticity of -2 for my wife, and elasticity of 0.01 for my mother-in-law. And in general, if the absolute value of the elasticity term is less than 1, then we call it inelastic, or you could think of it as being relatively unresponsive. And if the absolute value of the elasticity term is greater than 1, then we could say it's elastic or responsive. So is the percentage change in the dependent variable greater than or less than the percentage change in the independent variable? So for my wife, the amount that she responded was greater than the amount by which I changed my behavior. For my mother-in-law, I changed my behavior a lot. She doesn't really change her behavior at all. Alright, so elasticities are a great way just to report the relationship between two variables. In economics, when we're studying a market setting, there's a couple of elasticities that are of particular interest. Probably the most important is the price elasticity of demand. The price elasticity of demand just shows you the percentage change in quantity demanded when there's a percentage change in price. So it's the percentage change in quantity demanded divided by the percentage change in price. So price elasticity of demand just measures how much the quantity of a product demanded responds to a change in price. Or loosely speaking, it just measures the price responsiveness of buyers' demand. So we said there's a negative relationship between the price of a product and the quantity demanded. But the question is, for different products, how much does the demand fall when the price goes up? That's what the elasticity of demand shows you. If you just look at the demand curve, it shows you that when you increase the price from P1 to P2, the quantity demanded falls from Q1 to Q2. And notice that price and quantity move in opposite directions. There's a negative relationship. As one goes up, the other one goes down. So you'd expect price elasticity of demand to be negative. However, it is common to drop the minus sign and report elasticities as positive numbers, because we know in this case it's going to be negative no matter what. So sometimes they'll drop the minus sign when we're talking about price elasticity of demand, so just be aware of that. Alright, so let's just do a couple examples where we calculate the price elasticity of demand. So first example, if the price of oil increases by 10% and the quantity demanded falls by 5%, then the elasticity of demand for oil is, remember, the price elasticity of demand is just equal to the percentage change in quantity demanded divided by the percentage change in price. So the percentage change in quantity demanded is a negative 5% because it fell by 5%. And the percentage change in price is a positive 10% because it went up by 10%. So we have negative 5% divided by 10%, which is equal to negative 0.5. And here you can see on the graph what's going on. So the price rose by 10% from P1 to P2. The quantity fell by 5% from Q1 to Q2 for oil in this example. So using this calculation, we're finding that the price elasticity of demand over this range is negative 0.5. Alright, second example, try to do it on your own first. So say the price of diamonds increases by 100% and the quantity demanded falls by 10%, then what is the elasticity of demand for diamonds? So go ahead and calculate it really quick. Now remember, the key here is just remembering what goes on top and what goes on bottom. So it's the percentage change in quantity demanded divided by a percentage change in price. So the 10% goes on top and the 100% goes on bottom. So we have negative 10% divided by 100% is equal to negative 0.1. So in the previous two examples, they just gave us the percentage change in price and the percentage change in quantity demanded. So it's already in percentage form. So we just had to divide the two numbers. Right? Often it's not going to be that easy. They're going to give you the raw numbers and you're going to have to calculate the percentage change. Now the standard way of computing a percentage change is to take the difference between the two numbers and divide by the initial value. So for instance, if the number of students in a room increased from 10 to 11, that would be a 10% increase the way that we normally calculate it. How do you get that? Well, you take the difference in the two numbers, so the n value minus the start value, so 11 minus 10, and divide by the start value, which is 10, and then multiply by 100 to put it in percentage terms. So you just have 1 over 10 times 100 is 10%. Let's do an example here. Well, just imagine that you want to start a business where you set up websites for other people, and let's say that, right, and how much you charge for setting up somebody's website is going to influence how many people buy your service. So for a business, the price elasticity of demand is really useful information. Okay, so you want to know, if I increase my price, how much is my business going to fall off by? You know these two things are inversely related, but more important to know what's going to change more, the change in price or the change in quantity, because that's what's going to influence your revenues. So, for instance, let's say that you know that if you charge $200, 12 people will hire you to set up their website, but if you charge $250, then you're only going to get 8 people to hire you. Here we can look at your price elasticity of demand for your websites. So to calculate the price elasticity of demand for your websites, you want to take the percentage change in quantity demanded and divide it by the percentage change in price. So if we're just going to use the standard method of computing percentage changes, we would just take the end value minus the start value over the start value and multiply it by 100 for both price and quantity. So for instance, if you started at point A and went to point B, so the price went up by $50, the quantity would fall by 4. So the percentage change in price would be after minus before over before times 100, or 250 minus 200 over 200 times 100. So you have 50 over 200, or you would just have 25%. Okay, but there's a problem with calculating it in this way, which is that the standard method gives different answers depending upon where you start. So using this method, if you calculate it going from A to B, you get a different answer than if you calculate it going from B to A. So going from A to B, the price rises by 20%, the quantity falls by 33%. So we just already calculated the rise in price as being 25%. To find the change in quantity, you would just take 8 minus 12 over 12 times 100. So 4 over 12 times 100 is 33%. You have 25% for the change in price, 33% for the change in quantity. So you have 33 over 25, or the elasticity is 1.33. But if you calculate it the other way, make B the starting point and A the end point, then you get a completely different number for the elasticity, and that's not good. All right, so doing it that way, we have after minus before over before times 100. So we have 200 over 250 over 250, or 50 over 250 times 100, which is 20%. And we have 12 minus 8 over 8, or 4 over 8, which is 50%. So calculating the elasticity in that way, we'd have 50 over 20, which is 2.5. Right, so we're getting a different measure of elasticity depending upon whether A is a starting point or B is a starting point, and we don't want that. We want the elasticity between point A and point B to be the same regardless of whether or not we start at point A and move to point B, or start at point B and move to point A. So the way that we solve this is by using the midpoint method of calculating a percentage change instead of the ordinary method. So instead of taking the change over the initial number, we're going to take the change over the average of the two numbers. So you have the end value minus the start value over the average of the two numbers, or the midpoint. The midpoint is the number halfway between the start and the end values, or the average. And if you use this formula, then it doesn't matter which set of numbers you use as the beginning and which set of numbers you use as the end, as long as you're consistent. So using the midpoint method, the percentage change in price is the difference in the numbers over the average in the numbers. So the difference in the numbers, 250 minus 200, the average of those two numbers is 225. So you just have 50 over 225 times 100, which is 22.2%. The change in quantity is the difference in the two quantity numbers divided by the average in the two numbers. So the difference is 12 minus 8, the average is 10. So you get 4 over 10 times 100 is 40%. So the price elasticity of demand, remember, is percentage change in quantity demanded divided by percentage change in price. So you have 40 over 22.2 is equal to 1.8. Right, so remember the formula. The way that we're going to calculate percentage changes for doing elasticities is the midpoint method. So you take the difference over the average, multiply by 100, that gives you the percentage change. All right, so some goods are more responsive to price changes than others. For some goods, the price elasticity of demand is greater than for other goods. Let's look at a few examples and try to draw some lessons about what determines the price elasticity of demand. Okay, so let's look at breakfast cereal versus sunscreen. So let's say that the price of both of these things rises by 20%. For which good do you think the quantity demanded would drop the most, and why? Okay, well, you can think about it on your own for a while. But the key here is the availability of substitutes. Breakfast cereal has a large number of fairly close substitutes. So people like to have breakfast, but there's a lot of different kinds of breakfast cereals. Right? There's also a lot of close substitutes for cereal. So most people like pancakes or Eggo, waffles, or leftover pizza for breakfast or whatever. So if the price of cereal goes up a lot, increases by 20%, so maybe it goes up by a buck, people will stop buying as much cereal and buy other things for breakfast instead. Right? So it's fairly sensitive to price changes, empirically. Now, if you look at something like sunscreen, that doesn't have any really close substitutes. So even if the price goes up by 20%, consumers would buy almost as much as before. The elasticity of demand for breakfast cereal is greater than the elasticity of demand for sunscreen. Elasticity is greater for breakfast cereal. Breakfast cereal is more elastic than sunscreen. It's more responsive to a given percentage change in price. So the lesson here is that elasticity is related to the availability of substitutes. If there's more close substitutes for the good, then there will be a greater change to any given percentage change in price than if there's not very many good substitutes. So if there's few substitutes for the good and the price goes up by a lot, people will buy almost as much as they were before, because there's nothing else to switch to. All right, here's another example. Do you think people will be more responsive to a price change in blue jeans or a price change in all clothing? So let's say that the price of blue jeans went up by 20%. What do you think would happen to the quantity demanded? And then imagine that the price of all clothing goes up by 20%. What do you think would happen to the quantity demanded of all clothing? Right. So for which good, blue jeans or clothing as such, do you think the elasticity would be greater, and why? Well, here again, remember, the whole key is about availability of substitutes. For a narrowly defined good such as blue jeans, there are many substitutes. So if the price of blue jeans goes up, people switch to buying other kinds of pants like khakis or dress pants, or they can buy shorts instead, they could buy dresses. I mean, there's a lot of other things you can buy that more or less serve the same function as blue jeans. But there's relatively few substitutes for very broadly defined categories of goods. So the category of clothing or the category of food. There aren't too many substitutes for clothing in general other than living in a nudist colony. So the lesson here is that the price elasticity is higher for narrowly defined goods than for broadly defined ones. If the price of a particular brand of a product goes up, the quantity demand will fall by a lot because they can always switch to a different brand. If the price of things like all liquids went up, people would buy almost as much as before because you need liquid in order to survive. All right, third example, insulin versus Caribbean cruises. So let's imagine that the price of insulin went up by 20% and the price of Caribbean cruises went up by 20%. Do you think that the quantity demanded would fall by a greater percentage for insulin or for Caribbean cruises purchased, and why? Well, again, the whole point here is it's about the availability of close substitutes. So for a diabetic, insulin is basically a necessity. There's not very many good substitutes for insulin for a diabetic. So a rise in price would cause literal decrease in demand for the insulin. Right? The price of insulin could double and the quantity that diabetics purchase would be almost the same. Right? A luxury cruise is different. If the price goes up, people will find other things to do. So instead of going on a cruise, there's a lot of different options of entertainment. So if the price of cruises doubled, you can pretty much guarantee that far fewer people would go on cruises. Price elasticity is higher for luxuries than for necessities. Necessities tend to be price inelastic. Luxuries tend to be price elastic. All right, fourth and final example here. Consider the change in the quantity of gasoline that would be bought in the short run versus the change in gasoline that would be bought in the long run due to a change in price. So imagine that the price of gasoline rises by 20%. Do you think that the quantity that people purchase would drop more in the short run or in the long run, and why? Right? Well, again, the key is it's all about the availability of substitutes. There's not a whole lot you can do in response to a price change like this in the short run. So if the price of gas goes up by a lot, you're going to buy almost as much as before. So I mean, even if it doubled tomorrow, you still got to go to work, you still got to drive around. So obviously you'll buy less gas, but you won't have an opportunity to adjust your behavior very much. Right? But the longer you have to adjust to this price change, the more you can think of ways of cutting back your use of gas. So you can start doing things like moving closer to work, or carpooling, taking the bus, buying more fuel-efficient cars, switching over energy from gas to electric, or whatever it is. Right? There's a lot of ways to conserve on gas. There's a lot of substitutes for gasoline, and in the long run, there's more substitutes than in the short run. So the lesson here is that price elasticity is higher in the long run than in the short run. This table summarizes what we've learned about the determinants of price elasticity of demand from the previous 4 examples. Goods tend to have a more inelastic demand if there's fewer substitutes for them. They tend to have a more elastic demand if there's more substitutes. Inelastic goods tend to be necessities or broad categories of goods. Elastic goods tend to be luxuries or narrow categories of goods, like particular brands. And the demand for a good is more elastic in the long run than it is in the short run. The price elasticity of demand is closely related to the slope of the demand curve. So for any 2 straight line demand curves, the steeper curve is more inelastic, the flatter curve is more elastic. Let's take a look at a couple of different demand curves and how they're drawn. So for a perfectly inelastic demand curve, this is an extreme case where no matter how much the price rises or falls, the quantity that consumers buy doesn't change. So this is hardly likely in practice. In fact, you're never really going to see a demand curve that's perfectly vertical like this throughout the entire range of price. The price keeps going up enough, eventually people run out of income and they'll be forced to purchase less. But demand curve could be vertical through some range of prices. And all this is showing you is that the quantity demanded by consumers is completely unresponsive to changes in prices. So like even if the price doubles, the quantity demanded stays the same. So something like insulin for diabetics might be close to this. This would be for an extreme necessity. Right? So even if the price goes up by a lot, the quantity demanded really doesn't change at all. An inelastic demand curve is a steep curve, and here it just shows you that the percentage change in quantity demanded is less than the percentage change in price. So the ratio of these two things is going to be less than 1 when you divide the percentage change in quantity demanded by the percentage change in price. A steep curve is inelastic. So here's showing you that a price falls by, let's say, 10%. The quantity demanded increases by less than 10%. Okay, so for a large fall in price, there's a small rise in quantity demanded, and vice versa. There's also such a thing as unit elastic demand. So this is showing you that the percentage change in quantity demanded is the same as the percentage change in price. So if the price falls by 10%, the quantity demanded rises by 10%, and vice versa. For goods with an elastic demand, the demand curve is flat, which indicates that for a given change in price, there is a large change in quantity. If the percentage change in price is 10%, the percentage change in quantity is going to be more than 10%. So the ratio of these two things is greater than 1 when you divide percentage change in quantity by percentage change in price. Finally, we have a perfectly elastic demand curve, which is the other extreme. And here, even if there is an infinitesimally small change in price that causes an infinite change in quantity demanded, what this is showing you is that at a price above P1, quantity demanded is going to be 0, and as soon as it hits P1, the quantity demanded is going to be infinite. So if you divide the percentage change in quantity demanded, which is infinite, by the percentage change in price, which is 0, you get infinity. So to summarize, the steeper the curve, the more inelastic or unresponsive the demand for the good is to a change in price. The flatter the curve, the more elastic or responsive the demand is to a given percentage change. After calculating the price elasticity of demand, you determine whether it's elastic, inelastic, or unitary elastic with the following rule. If the absolute value of the elasticity term is less than 1, then it would be demand inelastic. If the absolute value is equal to 1, it's unitary. If the absolute value is greater than 1, it's elastic. Demand elasticity is greater than 1 implies elastic demand, less than 1 inelastic. And again, because the price elasticity of demand is always negative, the sign on the coefficient is often omitted in discussions. Here's just a few elasticities from the real world. So it's showing you percentage change in quantity demanded divided by percentage change in price. So how responsive are these goods to given percentage changes in prices? So things like salt, matches, and toothpicks are very inelastic. And here's one more rule, which I didn't cover in the previous examples, which is that if something's a really small part of your budget, then a large percentage change in price really isn't going to be noticed. So for something like salt or matches or toothpicks, I mean, you don't spend much money on it, and it's so cheap that even if the price doubled, you'd hardly feel it. You might not even notice it. But for something like a car, if the price doubled, it's such a large expense and it's such a large part of your budget that you would definitely notice that, and it would definitely influence your behavior a lot. So gasoline is price inelastic. So if the price goes up a lot, people tend to buy almost as much as before in the short run, and then in the long run they adjust their behavior a little bit more. Things like tobacco, alcohol, things that people are addicted to, or things that people need, those are things that are going to have inelastic demand. And things with elastic demand tend to be more luxuries, things like foreign travel or meals at fancy restaurants, automobiles, which are a large part of the budget. Then you have things that are approximately unitary elasticity. So if the price of movies goes up by 10%, people go to 10% fewer movies. So this is kind of an interesting thing to look at.
All right, well, there's one final concept about price elasticity of demand that you need to know. And this concept is very useful for a business. The price elasticity of demand tells a business whether raising the price of its product would increase or decrease its total revenue. The total revenue that a business takes in is just equal to the price of its product times the quantity of its product that it sells. So for instance, if you're operating a pizza place, if you're selling pizzas for $10 a piece and you sold 100 pizzas, then the total revenue that you would take in would be $1,000, $10 times 100 pizzas sold. Of course, costs are important too, but revenue is half of the story. So knowing the price elasticity of demand is very useful for a business. Continuing with our example from before, imagine that you were thinking about setting up websites for people and you weren't sure whether to charge $200 or $250. Well, this idea of price elasticity of demand could give you some insight. Remember that if you increase the price of your product, it's going to have two effects on revenue. The higher price means that you're going to get more revenue for each unit that you sell. So if you raise the price from $200 to $250, you're going to get an extra $50 for each person that comes in and has you set up a website for them. But at that higher price, you also sell fewer units, or in this case, you'll get fewer customers coming in. So the question is, which of these two effects is bigger? And the answer is that it depends on the price elasticity of demand. The price elasticity of the demand tells you the information that you need to know. Remember that the price elasticity of demand is just equal to the percentage change in quantity demanded divided by the percentage change in price. And total revenue is equal to price times quantity. So if the demand for your product is elastic, then the percentage change in quantity is greater than the percentage change in price. So if you raise the price of your product, the fall in quantity is going to be greater than the rise in price in percentage terms. So your total revenue is going to fall. Here's a graph with an elastic demand curve that illustrates this. So remember, an elastic demand curve is a flatter demand curve. The rectangle from the price out to the demand curve and down to the quantity demanded is equal to the total revenue. So remember, we said that total revenue is equal to price times quantity. So if you charge $200 for your product here, quantity that people would buy would be 12. So your total revenue would be equal to 200 times 12, or $2,400. That's equal to the rectangle 0, 200 over to the demand curve and down to 12. Conversely, if you charge $250, you go over the demand curve and down, and this shows you that you only have 8 customers. So the total revenue that you take in would be equal to $250 times 8. So the total revenue would equal $2,000. So if the demand for your product is elastic like this, then an increase in price causes your total revenue to fall. Or a decrease in your price would cause the total revenue to go up. That's for an elastic demand curve. Now, if the demand for your product is inelastic, then the opposite is true. If the demand for your product is inelastic, it means that the percentage change in quantity is going to be less than the percentage change in price. So if you raise the price, the quantity is going to fall, but it's not going to fall by as much as the price goes up. So on net, total revenue is going to increase. Here we have an example of a product with an inelastic demand. So it's a little bit steeper than the other one. Remember, this inelastic demand means if you raise your price, the quantity demand is not going to fall as much. So the total revenue, if you charge $200, is the same as before. So total revenue would still be $2,400. But if the demand were inelastic, then if you raise the price to $250, the quantity demanded would only fall to 10 instead of 8. So if you increase the price of your product to $250, the total revenue is going to be equal to $250 times 10, or $2,500. So notice that in this case, if you raise the price, your total revenue is going to go up. So if the demand for your product is inelastic, an increase in price causes total revenue to rise, and a decrease in price causes the total revenue to fall. And that's it for the price elasticity of demand. There's other price elasticities that are important. One is the price elasticity of supply, and it's almost exactly the same as the price elasticity of demand, so it's not worth spending that much time on it. The price elasticity of supply is just equal to the percentage change in quantity supplied divided by the percentage change in price. So remember that the higher the price of a product, the greater the quantity supplied, and the lower the price of the product, the lower the quantity supplied is going to be in a marketplace. So if producers can get more money, a higher price for selling their product, you're going to sell more of them than if they can get a lower price. So this price elasticity of supply is just measuring how much quantity supplied responds to a change in price. And loosely speaking, it just measures seller's price sensitivity or price responsiveness. And again, we just use the midpoint method to compute the percentage changes. It's almost exactly the same, except in this case it's going to be a positive number because there's a positive relationship between quantity supplied and price. So here we have a supply curve. It's upward sloping. And let's just say that if the price rises by 8%, the quantity that people produce goes up by 16%. Well, in that case, the elasticity is going to be 16% over 8%, or it's going to be equal to 2. So that's an example of an elastic supply. Again, if the elasticity is greater than 1, we call it elastic. If it's less than 1, then it's inelastic. So it's basically the same as for the demand curve, only like I said, in this case there's a positive relationship between price and quantity supplied. So it's just a percentage change in quantity supplied divided by the percentage change in price, and you calculate everything exactly the same way that you would do for the demand curve. And just like for the demand curve, if the supply curve is perfectly vertical, then it's a perfectly inelastic supply curve. So a change in price has no effect on the quantity supplied. An inelastic supply curve is a steeper curve. There's such a thing as a unitary elastic supply curve. So if the price goes up by 1%, the quantity supplied goes up by 1%. Or if the price goes down by 1%, the quantity supplied goes down by 1%. An elastic supply curve is rather flatter, and a perfectly elastic supply curve is horizontal. All right, we're just going to look at two other elasticities very briefly. So the income elasticity of demand is interesting. That just measures how much the quantity demanded changes in response to a change in somebody's income. So for a particular product, if consumers' income goes up, what happens to the quantity of the product that consumers buy? So it's a percentage change in quantity demanded divided by a percentage change in income this time. So income is the independent variable now instead of price. So remember, in Chapter 4 we talked about the difference between a normal and an inferior good. For a normal good, if your income goes up, you buy more of it. For an inferior good, if your income goes up, you buy less of it. So this is just a slightly more precise and technical way of telling whether a good is a normal good or an inferior good. For a normal good, income elasticity is greater than 0. So it's positive. So if the income goes up, the quantity of the good that people buy goes up. Or if their income goes down, the quantity they buy goes down. They move in the same direction. So for normal goods, income elasticity is greater than 0. For inferior goods, income elasticity is less than 0. It's negative, meaning that there's an inverse relationship between income and the quantity of the good that people buy. So for inferior products like ramen noodles or the things that people don't buy when their income goes up, as their income goes up, the quantity that they purchase goes down. The income elasticity is less than 0. It's negative. And finally, you can look at cross-price elasticities of demand, which just measures the response of demand for one good to changes in the price of another good. So the cross-price elasticity of demand for two goods is equal to the percentage change in quantity demanded for the first good divided by the percentage change in the price of the second good. So now we're looking at the price of related goods. And again, this is just a more technical way of looking at substitutes and complements. Remember that the price of related goods can influence people's demand for a product. If two goods are substitutes, if the price of one of the goods goes up, the demand for the other good goes up. Remember, substitutes are good replacements for one another. So like if the price of margarine goes up, the demand for butter goes up. Right? People stop buying margarine, they start buying butter. In that case, there's a positive relationship between the price of the first good and the quantity demanded of the second good. And the opposite is true for complements. Remember, complements are things that tend to go together. So an increase in the price of one good is going to cause a decrease in the demand for the other good. So if the price of peanut butter goes up, the demand for jelly goes down. So these two things move in the opposite direction for complements. Okay, I think that's it for elasticities for today. As always, I hope you got something out of it, and take care.